This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make wind turbine lightning protection easy. If you're a wind farm operator, stop settling for damaged turbine blades and constant downtime. Get your uptime back with our Strike Tape lightning protection system. Learn more in today's show notes or visit weatherguardwind.com/striketape.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. I'm your co-host, Dan Blewett. On today's show, we've got a great guest. Martin Huus Bjerge from Rope Robotics is here. He is going to talk about his company, his technology, as they are out repairing leading edges of wind turbine blades all over the world. So, Alan, really interesting discussion today with Martin. They are doing a lot of cool stuff with robotics, helping to get these leading edges cleaned up. What were some of your takeaways from today's talk?
Well, Martin and Rope Robotics have evolved the robot technology over the last couple of years to be very efficient at removing old leading edge protection and then cleaning the blade and applying a much more resilient leading edge erosion surface to blades. And that's taken several years of engineering time, technology, building to come to the platform they have today. And that platform is really versatile. And I think that's the key to what Rope Robotics has done, is that they have a technology that can be commanded from halfway around the world. So not only can it do the repairs and provide all this data, it can also be commanded remotely. So it's just an extremely versatile tool. And I think that's the part I pulled out of from Martin was how good this technology is. Because right now we're repairing leading edges with rope technicians. That's what we're doing, and it's sort of a manual process. And Martin's company is going to make it a lot more automated.
Yeah. So in today's talk, you'll hear a lot about the actual sort of nuts and bolts. I guess quite literally the technology in the robot itself, how it works, how they apply their solution, all that sort of stuff. Also about how the company was founded, which is really interesting. So they were sort of incubated by Siemens because Martin was a longtime employee of Siemens. So he, cut his teeth learning about all the ins and outs of a big, obviously, wind energy company. And when he had this idea, brought it to his management, and they said, "Yeah, we actually support you, getting your company off the ground and doing some R&D." And they were really, like I said, helped incubate his company, and he still has a strong sort of partnership with Siemens, which is really unique and interesting. And that's one of the big challenges a lot of small businesses face is getting their idea from concept to prototype to actually out in the field. So that evolution with him is really interesting, and he goes into that. And then lastly, we talk a lot about jobs and automation and how people do fear that robotics and drones are going to take the jobs of wind techs, but really more and more people, pretty much everyone we've talked about, and I think, Alan, you correct me if I'm wrong, I think you agree as well that, automation is probably just going to allow people to have easier jobs and do the same work and also open up a lot of new ones in data analytics and all these associated adjacent kind of fields. I mean, is that how you sort of see the way robotics is going to interact with the humans that control and still have to supervise and take over and monitor?
Yeah. Well, yeah, there's definitely going to be more jobs in the robotics field and more technicians needed. The growth in the wind turbine industry is going to overwhelm any advancements in automation. The number of wind turbines that's going to be put offshore and onshore are going to explode in the next 10 years. And with that, it's going to come a huge need for technicians, and then technicians, they can operate robots. That's what's going to happen. So it's an evolving technology, and if you're a rope technician now, gaining that extra piece of skill set of being able to also control a robot and understand what the new robots that are coming online are, is going to make you more valuable. It's going to increase your pay. It's going to expand your horizons, and those are all good things.
Yeah, and I think at the end of the day, it's not like C3PO is coming, to take your
No.
job.
No.
It's these are new tools that you'll use on the job, just like a new saw, and using your iPad. We didn't use iPads on construction sites years and years ago, right? This is all just essentially it's a new thing to make your job easier, and that's, I think, an interesting takeaway from all this. So, without further ado, let's jump to our conversation today with Martin Huus Bjerge with Rope Robotics. All right. Well, Martin, welcome to the show. Thanks so much for sitting down and chatting with us.
Thank you very much. A pleasure to be here.
So we were just chatting off camera that this makes our introduction really easy to talk about the BR8, which is your current model of robots right there in frame with you. So take us through it a little bit. I mean, that thing looks beefy. It looks cool. Like, we know a little bit about what it can do. We're excited to hear more. So tell us a little bit about the BR8.
Yeah, thank you very much. So the BR8 is a robot that we developed here in Rope Robotics with the purpose of doing blade maintenance. And first off, we started out with looking at the leading edge erosion problem. And so far we've made all the tools for the robot to be able to perform that tasks. So that means we can navigate the blade. We can get up there, move around on the blade. We can do some cleaning of the eroded area. We can sand it. We can prepare everything. We can apply some coating, and then in that way fix eroded blades. And then on top of that, the idea is with the robot that we will be able to do many other tasks on blades in the future. So the basic structure of the robot is that it's a modular platform. So right now we have all the tools for the leading edge erosion repair, but we will be able to equip it with all kinds of different tools so we can fix pretty much any problem on a blade in the future. So that's kind of the very basic and simple part of the robot so far.
Okay. And correct me if I'm wrong, but leading edge erosion is your main focus right now?
That is our main focus for sure at the moment. And this is basically, we did some business studies and market studies in the very beginning of the company and looking into this. And here it was easy to see that leading edge erosion is pretty much 50% of the whole market of blade maintenance at the moment. So so that was kind of the reason for choosing that. Of course, you could have chosen other areas of the blades to start with that might have been easier as well, because I think we got some learnings also with that part. It's fixing a leading edge is not that simple, actually. It's a quite complex process, and you need to get it all right before you actually have a product. So it really takes some effort to get there, but it's pretty much there now. So we're ready to go out and repair some blades this summer. So looking really much forward to getting the robot out there in the market.
Yeah, so obviously, when you think about what a robot can do, with as little human intervention as possible, it's definitely going to lend itself to some solutions to problems rather than others. So you guys are using wet solutions, like you're not using tapes with the robot. Is that correct, to fix some of these leading edges?
Yeah, so I kind of split the solutions for leading edge erosion into three categories. So there's the tape solution, there's the wet solution, and then there are the shell solutions. And we're putting ourselves in the wet solution category. And that's, we did some thoughts in the very beginning. What do you think is the best way to work with a robot? And there we came to that wet solution is probably the best and the easiest way to do it with a robot. And of course, in the wet area, there are different kinds of solutions. We started out with using some paint coating solutions. I actually have. So this is a spray paint so that was what we did in the very beginning, trying to have the robot spray paint the leading edge. And this is also a LEP, so it is a strong coating that works very well on the leading edge. But it's really difficult to control this spray process when you're up there on the blade and you have a lot of wind, and just makes it very difficult. Yeah. So today we are actually more into some more you can say high viscosity material, so not something you spray on, but more a coating where it's where it's mixed in a mixing tube, and then we're putting it on with a squeegee like. And scraping it on the blade in that way. So that's kind of where we ended up, and it looks really promising for doing leading edge repair. And we've done a lot of testing here in our workshop where I'm sitting at right now, actually, and we have blades here, and we have and now we've done a couple of turbines the last couple of weeks, and everything looks really promising. So looking forward to get a lot of turbines done this summer.
So if you're listening and you're not watching, so we have a YouTube version as well. I highly suggest you jump over because Martin's got a good setup here in his workshop. You can see the robot, and he's actually got a couple in frame. So we always do a YouTube version in addition to our Spotify, iTunes, all our other podcast platforms. But in this case, Martin's he's crushed it with his backdrop here. So if you want to check out what he's working with, be sure to hop over to YouTube. So, I mean, with leading edge erosion, the pitting and the erosion on the edge of the blade is going to vary heavily. So I feel like that, the thicker viscosity application is you probably found that was going to fill cracks a lot better and that those pits better than the spray modules, is right?
Definitely. I think that's also one of with the spray solution we started with there. You need to kind of have a process where you sand the blade, you clean it, then you apply some filler material to kind of rebuild the shape of the blade, and then you do the spray painting. With the new LEP material we're using, there you basically skip the whole filling process, or you can say that you either you skip the filling or you skip the paint. I don't know which of them you skip, but you basically merge them together. So you take out one process of the whole equation, and that saves really a lot of time when you're repairing the blade as well. So doing it faster and cheaper, and actually getting a better result as well. So very, very nice.
So let's talk about how you got to where you are. So obviously that's just one good example of iterating and learning from doing, right, and evolving with your solution. Let's talk about the robot as well. So the BR8, your current model, what kind of iterations did that go through? How long did it take to develop? Like, tell us about the platform itself and how you got to where you are.
Yeah, so a little bit of history. We started 5 years ago with the company, and actually before starting the company, there was a lot of conceptual investigations and figuring out exactly how do we do this. But in the very beginning, we focused on how should we navigate the blade. So there was some iterations about how we're using ropes to carry the weight of the robot, and then using vacuum to make sure we have a stable connection with the blade. And we're working on various methods for doing that. And there we actually ended up with a solution where we were kind of moving in small steps on the blade with the use of vacuum. And it worked kind of nice, and we were able to have a stable connection with the blade. Then from there, we developed all the tools and getting that part of the robot up and running. So now we're able to navigate the blade, and now we are starting to have the tools to actually do the whole repair process. And with that, we came to now we have a solution. We have a robot that's actually able to do repair of leading edge, but came to the conclusion that we still need some more speed into this. It's able to do it, but it's not fast enough yet. And that's where we kind of did a little bit of change in the strategy on our design. So now we have made a new navigation system of the robot. It's still ropes and vacuum, but it's now made in a way so it can slide on the blade. So we can move actually while working on the blade. So we're not moving in steps, but more moving continuously. And we also redesigned the tools so we can now do the repair continuously. So going from a discrete repair where you're repairing sections of approximately 1 meter, now we can do a repair of like 5, 6, 7, 8 meters in one go.
So Martin, the incremental improvement of the robot has gotten to this point where now you can do multiple sections of a blade pretty quickly. How does that look like in terms of the steps that you do to apply your new wet material? What's the process there?
Yeah, so the process is you can say actually quite simple. It's you sand the blade, and I have a sanding tool here, maybe quite easy for you to see. So this is a tool mounted on the robot, You have this is sandpaper on brushes. So this rotates, and you have the leading edge here, and then you basically just slide up along the leading edge while sanding everything on the leading edge.
Is the robot doing the braiding the pressure side and the suction side at the same time, or are you doing the pressure side and then coming around to the suction side? How does that go in the sanding?
Yeah, so the very nice thing about this this tool is that it actually does the whole leading edge, so both pressure, leading edge, and suction side at the same time. So it's this the shape of this wheel on this sanding tool is taking care of everything. So we're taking with this tool, this current tool, we're taking something like 5 centimeters to each side of the blade is taken care of in one go. So when that's done, then you would do a cleaning process. Pretty much the same tool. Instead of sandpaper on these brushes, it's just cleaning brushes, and then we add some isopropyl alcohol, so we get a nice and clean surface. And when that's done, then we apply the LEP coating, and there we have of course this is a completely different tool, but a tool that will dispense the material through the mixing tube, and then have a squeegee touching the blade and shaping the material, so you get a nice smooth surface. So that's the basic process. Then the process is the same, but we have actually 2 different LEP application tools for, you can say, the very tip of the blade, the outer 1 meter of the blade, and then the rest of the blade. There we have a different tool to take care of that. So we did a lot of testing and trying. How do we do this? Because there's very big difference between the leading edge on the very tip of the blade, and then the rest of the blade. It's much more narrow and everything. So there we decided to go with 2 different tools for that area of it.
How adaptable is the robot to the different manufacturers' blades, kind of like a Siemens blade to a Vestas blade to a GE blade? Is your robot adaptable to all the varieties of blades that are in service? So
it's been a target of our design all the way to make it flexible and adaptable as much as possible. We have mainly been working with Siemens blades so far, and that comes a little bit with me having a background in Siemens and good connections there. But that means that's where we have the most experience so far. But we have been working on some LLM blades as well, so we can work on pretty much anything. And we're not, you can say, even though we've been working on Siemens blades, it's not because we have the CAD drawings and everything from the blades. So we're working on the blade no matter the shape of it. So it's adaptable tools. Of course, there's some limitations, and I haven't tried all blades in the world yet. So we probably gonna end up on some blades out there that give us some hiccups, and we need to go back in the lab and do a little bit more work on that.
And then, as far as speed, because you mentioned speed, how long does it take your robot and the techs who are going to control it to do one blade, one turbine, one job, one site? Like, what is the current level of speed?
So currently we've been working with something like a blade a day, 1 to 2 blades a day. But my expectation is that during this season we will achieve 3 blades a day with a robot. Their setup we're going to do is something like having 3 guys, 2 robots, and then the target is within 21 we will be able to have these 3 guys, 2 robots, complete 2 turbines a day. So 2 turbines a day. Wow. That's and 2 robots. That's the target for this year.
Tell me about the human element here. So you said 3 technicians working 2 robots can complete 2 turbines a day. That's your goal for 2021. What's the role of the 3 humans? If it's one person, maybe actually directing the robot, then is the third sort of just supervising, helping out, lending an extra hand? How does that sort of orchestra work?
Yeah, so there's you can say in the morning when you arrive at the turbine, there's some rigging jobs to be done. You need to prepare the robots, getting the ropes rigged on the turbines. You climb the tower, you attach ropes in the nacelle, lower them to the ground, attach it to the robot. In that phase, there you need to be a few people. Ideally, you would actually be 4 people in that phase, but 3 people, that works quite well, and you can get that job done. Then during the day, you would have 2 people controlling the robot and doing, you can say, all the behind the computer screen and decision support for the robot, that part of it. And then you have an extra guy being standby, and that means when you have to take a robot down to reload it with some consumable materials, if you need to put another canister in a tool or something like that, then you have an extra guy in the field to support that part of it. So that's basically the setup.
And then as far as the tech's job, so the technician sort of analyzes the potential repair. He decides or she decides where and how long the repair should be. And then once he sort of like add all the parameters in, he's going to press go, and then the robot's going to sort of take over the rest. Is that an accurate depiction of it?
Yeah, pretty much. So it's I tend to say it's semi-automated. So we have the humans to do some decision power through the robot, deciding how much should be repaired, and when you've done a sanding, checking the quality, is that good enough? Do we need to do another run to make it up to the standards we require? And then when the technicians have approved the process, then they execute the next process. So semi-automated. And I think that's actually one of the areas where we in the future expect also to improve the robot and even automate even more. So you get some AI in there in the robot to assist the technicians in this decision making. And maybe in the future you would even be able to optimize that even more.
So Martin, what's the level of technology that's in the robot? What all is packed into that canister?
Yeah, so again, we have a lot of the complexity we have put into the tools, and that's basically also to keep the robot flexible and modular. But the robot, the locomotive, as we call it itself, has there's the drives for the motors where we're coiling up ropes. So that's basically adjusting the distance on the blade. Then there's the robot arm and the controller for the robot arm. Then there's some pneumatic system in the robot, because it's not just tools. You actually need to be able to pick up these tools and place them back on the robot again. And this is all done with it's pretty much standard robot tool change equipment, and that is all pneumatic controlled in our system. So there's a quite complex pneumatic system there to handle that. And then there's some systems so providing an interface to the tools. So all the tools have also pneumatic interface. So we have some air pressure out there. We have some vacuum out there. Then there's electricity out there. So you have here in Europe we're running 230 volts. So that's 230 volts AC to the tools, and we have some 24 volt supply. We have some serial communication, stuff like that. So all that is controlled from within the robot, and where we have the computer controlling everything. And then on the tool side, there you then build in whatever mechanics you need to do a specific job, and then you have all the I/O based on the serial communication you have with the robot. So there's quite a lot of stuff there. And then on top of that, we actually there's cameras. So we have 4 cameras on the robot, one on the robot arm, so you can always see what's going on with the tool. We have on each side of the robot and one pointing upwards. Then we have a laser scanner on the robot arm as well, so we can scan the surface of the blade and actually get a quite precise model of how does it look exactly here. We're thinking about in the future being able to scan the erosion, so you get a quite good model of what was your erosion like, and then I was involved in a research project together with DTU here in Denmark, and there we're trying to build models on quantifying the AEP impact and noise impact of your erosion. So that laser scanner is going to give us all the data for that part of it. Then we also have a force torque sensor to be able to measure what are the forces and impacts on our tools. Just quite a lot of stuff in there, and I probably forgot some of it all.
So I want to shift gears a little bit because you mentioned your background with Siemens, and we had chatted a little bit about how you got started. But you were in a lot of ways sort of incubated by Siemens. Can you tell us a little bit about what you did with them and how they sort of helped you guys, get this concept going? And because I feel like a lot of companies, they struggle to get that sort of, from concept to prototype, right? And then from prototype into a real world and actually out there on blades. I feel like that's a big challenge. So can you take us through that process? Because it seems like you guys that hurdle was actually pretty low for you and that you really kind of hit the ground running.
Yeah, I think we've been really lucky on that part and got some really great support from especially from Siemens getting started. So going way back, the idea there was me and a colleague in Siemens. We kind of got this idea of working on blades with robots, and that basically came from my colleague. He was doing some statistics on leading edge erosion and how widespread this is going to be in the Siemens fleet and the whole industry, and came to some. See, this is going to be quite a big problem in the whole industry, and talking about maybe we could do this in a different way than having people working from ropes and platforms and stuff like that. So there we came with the basic concept of a robot doing repair on blades, and we presented that to the management and said we would actually like to do a company based on this idea. And there we got a go to do that. And I think a lot of managers, a lot of companies said, sorry, can't support that. You have a job here, you need to take care of that. But I was really lucky and really grateful for our manager being supportive of this. So they helped us in that way, setting us free basically to work on this in our spare time and getting the concepts in place. So that's kind of the first part of it. Then in a Christmas holiday, we borrowed a laboratory in Aalborg University, and there we spent a couple of weeks during the Christmas to test out some of our ideas and concepts. And Hans, who I started this with, and me, we never tried to program a robot before, so that was kind of the first task, trying to figure out how do we write a program that could make a robot arm do some movements. So during this Christmas break, we did learn to program a robot, and we did a few small tools so we could actually sand a piece of leading edge and apply some filler to a piece of leading edge. And we also tested out some of these vacuum systems with moving on surfaces with use of vacuum. We got all of that tested in these 2-3 weeks and made some small videos and showed it to Siemens, and they were kind of impressed, say, okay, that looks actually promising. It's very basic and simple now, but looks promising. So, and we asked them, okay, if we get this up and running, would you be able to support us with some turbines to test this and stuff like that? We say, yeah, for sure, we'll be able to do that. And then kind of the whole dialogue with Siemens started, and they've been extremely supporting all the way through this, getting this up and running.
Yeah, I mean, Alan, you've worked in engineering and for all these different companies over the years. Is that common?
No, it's definitely not common. Large companies don't tend to want to have offshoots, and they don't know how to manage it. But in Martin's case, I think he had a very unique situation, and he used it to his advantage in a sense that there's a huge problem out there in leading edge erosion, and it's a very difficult problem to solve, obviously, because there's been so much research on it in the last even year or two. There's been a lot more research on it, and to go back and try to maintain the performance of all the blades that exist in service right now is a really, really difficult problem. And there's been a lot of different possible solutions out there, but I like Martin's because it's pretty straightforward, right? You want to clean off the erosion, clean off any contamination, and apply a really, really durable coating. The problem is that it has involved putting people on ropes to do it, and it's slow. And Martin has evolved some technology, and it was really interesting to hear all those different parts about Martin, about what's happening inside the robot, because from the outsider's point of view, it sounds simplistic, but it's not. There's a lot of technology in that robot to accomplish those that process, to accomplish that process repeatably. How has that some of the work you've been doing on blades been going? How's your consistency been? How has the progress been? How has the customer base been growing? How does that, now that you have a technology that's working, how is it going out in the field? What are you seeing?
When you're looking back, there's so many things that if you knew what you know today, you would have done it so much differently from the very beginning. And there's also times where you really love to being able to turn back the time just a little bit to have avoided these mistakes and stuff like that. But I think that's the nature of all basically all development, all R&D. I was hearing another podcast the other day where they're also talking about a lot of people have this perception that development and new technology happens in the blink of an eye, and somebody comes with a brilliant idea, and now we just have something new. That's not the way it happens. It happens in small steps, and then you get wires, and it takes time. And we've done a lot of iterations and tried a lot of different stuff off. So right now we're sitting here with what we think is best now, but I'm also sure that's going to evolve in the future. We're going to find more improvements and continue improving this. So this is where we are now. So right now, I think the main thing is we are at a place where the technology is ready to start making business on it, and there we really want to now get the product introduced to the market and starting to getting some revenue based on this and starting to make some money, because it's not free to run a company like this, having R&D engineers working day and night to get this up and running. It takes some money. So getting some revenue and starting to making some of this money back is definitely a big thing for us now.
And so let's talk about that. Let's talk about your business model. So are you selling robots? So if I own, a wind turbine inspection repair company, are you selling me one of your robots, and I'm going to learn how to use it, and I'm going to deploy it just like I would, any tool in my shed? Or do I need to contract you and you guys take care of all of it yourselves? Like how does that work going forward?
Yeah, so we're still trying to figure out the exact right business model for this, and we've been starting off by hiring our own technicians. So we have our own wind turbine technicians that are trained in using the robots and have all the certificates needed to be able to work in turbines. And in this way, we can sell the robot as a service. So you basically, if you had a turbine, you just give me a call and I will arrive in your wind farm with the robot and control equipment, all my technicians, everything, and we do the complete job for you. So in that sense, we're a service company doing the repair. But for us, that's more a way of getting started to show to the world that this is the product we have, and go out there and do some small, simple demos and basically showcase the robot. From there, the idea is to do partnerships with the existing service companies. I don't think we're going to be the best in the world to handle all the logistics and dealing with all the blue-collar technicians working out there in the field. I really have so great respect for these service companies taking care of all this. There's really a lot of complexities and logistics in handling all that stuff, making sure that goes on safely and at the right prices and in the right way. So that's why we would like to do partnerships instead on that area, and then we can focus more on the technology part of it. So that's going to be transforming from a service into more you can say maybe a franchise like business model, where they can buy or lease the robot from us, and then we will train their technicians in using it the right way.
Yeah, that makes sense. And I'm sure, Alan, that seems like that's going to eliminate a lot of that complexity, like you said, just logistically, where, you don't want to be trying to organize, 18 technicians in this state or in this country and that country and that. I mean, that just seems like a really big task. And like you said, that would probably drag you off of your core focus, which is making technology that works, like making a robot that really does a great job for whoever's operating it.
Martin, is one of the aspects of your robot is that it can be commanded offsite or controlled offsite through the internet. So is then if you were to franchise the robots out into service to different repair companies around the world, you still have ability to interact with that robot via the internet, right? You could still provide service over the web.
Yeah, exactly. So we actually done some testing on that already. We already represented in North America. So I have one of my technicians he's in Canada at the moment and has been working a little bit in the US earlier, and there I'm supporting him basically sitting here in Aarhus in Denmark. So when he's out there and like to get a little bit of support on what we're doing, then I just pull up a video feed from the robot and I see the whole control of the robot from here. And we actually did a small test. He wanted to prepare some of the tools for something. I said, okay, let me just try to take the control of the robot. So I was sitting here in our office controlling a robot operating in North America, and it worked smoothly and very well. So definitely, I see a future where we have a control center somewhere where we basically controlling the robots and doing this decision support for the robots from you can say an office location somewhere in the world, and then you have all the on-site handling of the robot with the rigging and preparing the tools and stuff like that is done on-site. And then in that way you would have these 2 or 3 technicians. They would not be taking care of 2 robots. They might be able to take care of maybe 10 robots instead, something like that. So that's definitely an opportunity of improvement and efficiency.
And then, it seems like, especially as wind turbines continue to grow in size, right? They're gigantic. And as offshore, continues to spread, like, there's more capital allocated all over the world for offshore wind farms coming up. There's definitely going to be this harmony between drones and robotics and, like the data centers and the technicians themselves. I mean, how do you see the robot sort of fitting into this whole ecosystem? I mean, do you see it working side by side with, aerial drones? Do you see it, you collaborating with other companies? The whole task of just servicing the whole wind turbine market, just making sure all these things keep running. How do you feel like, Rope Robotics fits into that ecosystem?
I think it's pretty safe to say that the future of wind turbines is going to be equipped with a lot of robots and a lot of drones all over. So today you see drones mainly used for inspection and starting to become a little bit of transport of spare parts and equipment between a warehouse and the individual turbines. So drones I think they're gonna take more and more tasks in that way. And now we have our robot that can do work on the blade, but I definitely also see robots taking care of jobs otherwhere in the turbine. So it could be our robot could easily be modified to work on the outside of the tower if you need to do some coding or stuff like that, maintenance on the tower. But you could also see why not work on the inside of the turbine? You could have robots doing inspection tasks and maybe small maintenance tasks inside the nacelle of the tower. So I definitely see robots going into that. I even also see why don't we join robots and drones? So maybe the drones are the one moving the robots around. Today we have the robot hanging in ropes, but you could easily imagine in the future it was a drone carrying the robot. And I envision somehow you have a robot and some drones in your side office, and then you deploy them. You stop the turbine from your computer, you deploy them, they do a repair job, and then they land back in your side office. That's the onshore setup. In the offshore, it's even better,
Wow. That's amazing.
And you wouldn't even have to pet them or feed them. I mean, they don't, you can leave them at home alone. They don't get needy. Yeah, just good drone.
Of course, there's always a little bit, some of the technicians getting a little bit worried sometimes when we're talking robots and drones. I heard a story from another completely different business area, but someone implementing some small robots in hospitals here in Denmark, and they want to carry around medicine and stuff like that. And then they couldn't figure out. The docking station for charging the robots just stopped working, and then they put up a camera filming that docking station. It was something with the robot getting wrong into it, and then what they saw, it was a guy peeing into the docking station. So basically, one of the service technicians or one of the porters who was he was afraid of losing his job due to this robot taking away his task. So he's trying to basically make a bad story out of this, and stuff like that. I could imagine going to happen also with a robot like ours, that are technicians actually being afraid of this new technology taking their jobs. But as I see it, I've looked at some statistics also looking back, and all the automation done today and up till now has actually always created even more jobs. So for me, I don't see our robot as something going out there taking people's jobs. I more see it as something that is changing jobs. So you're going from one kind of job to another kind of job. You also have to be honest, you don't see a lot of rope access technicians out there being 60 years old or 65 years old, still hanging in ropes and working there. It's a tough job. It have a tendency of wearing you down. And in that way, you could say, maybe you have your first young years and you get your experience in ropes. And when you're getting a little bit older, you want to have a family and you don't want to travel so much anymore. Maybe being a robot operator is a better job for you at that time. So you can still be in the wind business, you can still be working with turbines and blades, but now you're doing it from behind the screen, or you're maybe doing it where you don't have to be hanging in rope, but you could use the lift in the turbine. In that way, it's a more safe and more easy job to do. So I think there's definitely a big part of this that is not just the financial part of doing it much cheaper to do the repair of the blades, but we're also doing it significantly safer, not just on the actual job when you're hanging in the blades, but also not wearing people out as much as done today.
Yeah, I think that's a good point, because you're right. I mean, with any physically demanding job, at some point, you're going to start to say, man, my aching knees, like, I just don't want to climb this thing today and be up in the swirling winds. Not to mention just thousands and thousands and thousands of exposures to anything, whether it's a construction site, whether it's working on cars. I mean, just the more exposures you have to just random risks, the more likely are. Like, I used to work on cars a lot in high school, and just if you put in enough hours, you're going to bust your knuckles on something. You're going to drop something on your face when you're underneath the car. Like, just even when you're careful and you're really good at what you're doing, like, little things are going to happen and they're going to add up. And sometimes you just, you twist an ankle, like you said, I think it really would provide a nice way to transition out where people don't see the end of their useful life and they're not put out to pasture like an old racehorse, like, yeah, I've been doing this for 20 years and I'm really good at it. And now I can be on the ground more rather than just always getting kind of beaten up, up on ropes, 400 feet off the ground, which is amazing and terrifying, and hats off to them, the men and women that do that job.
Yeah, exactly. I think it's quite impressive what these guys can do. And the guys I've hired in today is actually people that have been working from ropes and have this experience. And I really see how they appreciate being able to do a lot of this work from the ground and not being able to do that, needing to go up there. Of course, I also see sometimes they like to get up there again and just get a little bit of that work. And I think that's that's the nature. We also love what we did earlier and that kind of experience. And I see also that going quite well hand in hand with the robot, because there will be tasks the robot can't fix. Sometimes there is something, a damage so complex on the blade that it doesn't make sense to make the specific tools for the robot to fix that. Then we still have all these really well educated rope access technicians out there can save the robot. Go out there and fix what we can't do. So it's we're never gonna be able to work completely without these guys. I don't believe that. The human factor is the human is a really brilliant machine. It's really incredible what we can do with the human body and the human brain. It's really incredible. So I'm not being able to do that kind of AI in any nearby future.
Well, and Alan, we were just talking about wind turbine technician jobs on a recent episode. I mean, what's your forecast for the future here? I mean, do you see this kind of the same as Martin does? I mean, where do you see this job evolving in the future?
Well, you're definitely going to have experience on blades and understanding what the failure modes are and the types of repairs. You're going to need to have that knowledge base to do what Martin's doing, which is to do the repairs. You need to understand what's happening out there, and that part is just really hands-on. That's always going to be hands-on. What Martin then is doing is expanding the list of capabilities that the rope technicians need. They're going to need to be a little more computer savvy. Most of them are already, and understand some of the intricacies to specific robots, because that's where it's going. We're going to more robots, and understand what the data streams are coming back from the drones, because we're going to see a lot of drone data, and even Martin's robots take a lot of data while they're up there. So you're going to have to be just a little more adaptable, and when rope technicians tend to be very adaptable people. So I think it's a natural fit, right? So you have the right kind of people already in place. You're just going to expand the knowledge base. And I think that's a huge thing for as a rope technician and a repair person, is to have a broad set of skills, because it just makes you more valuable. So you can expect to see a little bit higher pay, a little bit better benefits, because you have those skills, and that's good.
Well, and that's one of the last things I want to touch on is data. So everyone's talking about data and collecting it, analyzing it, using it to track and forecast and all that. So Martin, are your robots just doing repairs? Are they also collecting data? If so, where is it going? And, how does that all sort of fit into what you provide for a customer?
Naturally, we collect a lot of data, of course. That's kind of the nature of drones and robots and automation, is that it comes with data as well. And my background in Siemens there, I actually worked with big data as well. So I was managing a team, a department where we taking care of collecting all the operational data from all the turbines, doing statistics, analytics on all that data. So I have a strong background in data, and therefore, of course, I also want to see that from the robot. So right now we focus a lot of the image documentation of what we're doing. So robot takes a lot of images of the work being done. You'd say typically a rope access, a platform team will also take images of what they're doing, but the robot is just even more persistent with taking all of these images, and you make sure that you get all the data about where you are on the blade, what is the humidity, temperatures, serial numbers on all the equipment, all that kind of information embedded in your images, so you know everything from that individual image. So it's really the advanced photo card that we embed in our images. Then, as I mentioned earlier, we have the laser scanner, where we would like to collect data about what is actually how does the blade look like, not just from an image perspective, but also looking at what is the 3D image, you can say, of this blade, and getting that kind of information.
I think in terms of just the amount of data, part of Martin's business is going to be just sort of data collection and data retention and interpreting that data, because in this new world we live in, and because Martin has incorporated so many unique pieces of information, the laser scanning, I think, is just unbelievable, right? That's a feature that's just off the charts good. But you're going to start having a lot of that data, and I think Martin's perspective on it is you're going to need people who are very skilled in that part. and then the big data, and that's where Martin comes out of, is obviously is the big data out of Siemens. So he understands that data is really key to success of wind turbines and the operation and the performance, right? It's not just walk out in the field like it used to be, look around and make sure that they're still turning. We're way beyond that now. And Martin, as that sort of data business grows, how do you see that being incorporated into your business? Because you're going to have terabytes of data.
Yeah, and I think that's an area that we haven't fully explored yet, exactly how that's going to be. And I think this is also an area where I want to team up with some other companies that are working already with this. So you can say a lot of the drone companies already are working intensively on how do we utilize the most out of the image documentation you get from drones, and they have a lot of data handling systems built already. So that would be obvious for us to kind of make a collaboration in that way with a drone company or someone doing some of these data systems for drone companies. So I definitely see collaborations in the business on this area. And then, as I mentioned earlier, with the research we done with some other Danish companies and with the universities, where we're trying to model when you have the blade and you see the erosion, what effect does that have on your AP from the turbine, and you have starting to being able to model that and being able to report to the customers. So you just get this because you have the robot anyhow up there and you have this information. Then we have a model that automatically provides you with information about what is the commercial upside of doing this repair. I think it's good information to get, and I think you could say, is that just nice to have feature, and why do we want to spend time with that? But you can say it's also something giving you input to how should you actually plan your repair, because if you can start modeling this level of erosion gives you this level of change in output from your turbine, and then comparing that with the cost of the repair and what is the utility, what is the energy prices in my area, and you can start modeling all that and figure out what is actually the optimal maintenance plan for my blade, not just a general thing, but individual for my wind farm. And I think that's just one way where you can see all this data really coming into to play.
Well, Martin, I think you're exactly right about that. And that's what makes the wind turbine business so exciting at the moment, is because they have a lot of what I would call smaller, mid-sized companies, which have very unique skill sets. And when you start connecting those companies together, then you have a very powerful set of tools. And if I'm a wind turbine owner, operator, or managing a site, I'm going to need to connect you up a little bit, because Martin's Rope Robotics has got this really interesting, very great technology, which is going to fix my leading edges, but it's also going to provide me data. Danny Ellis over at SkySpecs has all the drone data, and he has the software to sort of categorize the level of damage that goes on. And then you have a company like PowerCurve and Nick Gardern over there, which is analyzing some of those effects about the leading edge erosion and what effect it has on AEP. When you start connecting those together, you become more powerful. But because each one of those technologies is so technology intensive, and your robot technology is very technology intensive, you can't have all that. You can't have great technology coming out of a large corporation like that. It's going to take a lot of us smaller companies working together to really make the wind turbine operation so much better. And I think that's why your company is so interesting, because you're bringing a very unique set of technologies to actually to be in service and working, but also it connects to other technologies that a wind turbine operator may already be using. They may be using SkySpecs to do the drones, and you can incorporate that data into your knowledge base to go out and repair the leading edge. Those are game-changing, large-scale changes in the industry that are being brought by companies like yours. And I think that is really key. And this is why, as we talk to more and more small companies that are involved in wind turbine technology, it starts to put a framework around it. And as you grow, and you will grow, because I think technology is right on point, how do you see that integration working together? Have you worked with other companies to date about exchanging of data and how that those companies start to interchange together? Are you already starting to work some of those relationships?
To be honest, we've been so much focused on getting our technology up and running, so we're ready to go out there and actually prove to the market that now robots can actually repair blades. So that's simply not been. I haven't had the time to go into this area yet, to be honest.
Yeah.
I do, though. I have had some talk with some of these companies already. I know them; they know me, and
Sure. I bet they do.
And we have had these initial talks that we ought to do something together. But right now, to be honest, it's a little bit I'm the bottleneck at the moment on that part. But definitely we're gonna go there, and I think it's gonna be great as well. And again, I'm happy to work with all these companies because I don't believe that we can't do it all ourselves. And like my managers in Siemens says, also they can't do it also. They also need these small startup companies coming up with their technology and supporting the wind business. So I think we need each other, all of us, and I think that's great. It's very fantastic to be in the wind business and seeing all this new stuff coming along, and then having both these enormously big players like Siemens and Vestas and all of the big utility companies as well, and then there's still room for small startups like me, and also the other drone companies. Some of them are getting quite big now, but they also started small, and so it's really fantastic.
So, Martin, how can people follow up with you and your company?
So naturally, we have our own website, roperobotics.com. You're welcome to have a look there. We have a YouTube channel as well, where we're posting videos once in a while. It's not been so much over the winter, but we're definitely going to post some videos here during the summer when the robot is getting into operation again. And of course, we're also on social medias like Facebook, LinkedIn, etc. So yeah, please hook up, connect with us on all the different platforms, and then we'll share some more information with you guys.
Yeah, so as always, we'll link below. So if you want to follow up with Martin and his company, Rope Robotics, be sure to check out the description, whether you're on YouTube or the podcast platform of your choice. We'll have links. You can click right through. Martin, thanks again for coming on the show. We really appreciate it. This was a great talk, and it was really, really interesting learning more about your robotics and where you guys are headed in the future.
Thank you very much. It's been really a pleasure meeting you guys as well, and being a pleasure here talking about our product. It's always nice to share.
All right, that's going to do it for today's episode of the UPTIME podcast. A big thanks again to our guest, Martin from Rope Robotics. Be sure to follow up with his company, doing a lot of really interesting stuff, and definitely spend some time on YouTube checking out their robot, the BR8, in action. Be sure to subscribe to the show on iTunes, Spotify, YouTube, wherever you listen. Thanks again for watching or listening, and we will see you here next time on the UPTIME Wind Energy Podcast. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike-tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.